Hi everyone, my name is Adelia Chitra Sazkia, and today I'm going to review a journal titled Deep Learning Model for Twitter Spam Detection, written by Zulfikar Alam, Barbara Caminati, and Elena Ferrari. So, what is spammer? According to Oxford Dictionary, spammer is a person or organization that sends irrelevant or unsolicited messages over the internet, typically to large number of users, for the purpose of advertising, phishing, spreading malware, and etc. In Twitter, you can find there are many spam accounts that try to do bad things to another user. Previous research already tried to do Twitter spam detection by using machine learning methods. However, some spam accounts do some tactics such as mixing normal tweets, posting heterogeneous tweets, or buying followers from the third-party marketplace, and those tactics make the account look like a non-spam account. In order to overcome that, the author of this journal tried to design more accurate and robust deep learning-based model to detect Twitter spammers. There are two problem statements. The first is, how effective is the proposed approach compared with existing machine learning and deep learning-based state-of-art approach? And the second is, how effective is the proposed architecture compared with simpler architecture? The author used two methodologies for this research. The first is using text-based classifier, where it only considers users' tweet text, and exploit word-to-fact training method to learn tweet syntax. And the second is using combined classifier, where it considers both users' tweet text and metadata. The metadata that will be used are age of an account, number of followers, number of following, number of favorites, number of tweets, reputation score, following to followers ratio, number of character per tweets, and number of digit per tweets. For text-based classifier, it basically has three processes: embedding, CNN, and classification, where CNN has three layers: conf layer, pool layer, and FC layer. On embedding process, the tweet will be transformed before it goes to CNN. Each tweet is mapped to a matrix where each word in the tweet represented as a high-dimensional row vector. To make sure all tweet matrices have same length, padding technique is used at this process. On CNN, on the first layer, it will receive the input and computes a dot product between the filter and the input data. On pool layer, it will perform a downsampling operation, and on FC layer, it will generate an output vector. The last process is classification. Softmax function is used to predict the class score that will be able to identify a user who posts a tweet about something is identified as a spammer or not. For combined classifier, it combines the input text and metadata. The process using text input is the same with the text classifier. But when the input is metadata, after embedding process, there is a step called dense. At this step, researchers use a simple neural network of several fully connected layers to generate more accurate and extended feature vectors. After that, the result from CNN process and dense step is combined, and it will go through classification process. However, the researchers run a further set of experiments to see whether they can have the same gain in the performance if the proposed combined approach is changed by making it simpler. For this experiment, the researchers combine users' metadata to the tweet text feature without any pre-processing. There are two datasets for the experiments. For the first one is Twitter social honeypot. The users already classified as spammer and non-spammers based on tweet content, user behavior, and topological features. From the total of 2,461 users, there are 1,632 spammers and 829 non-spammers. And on the second dataset, the 1KS10KM, the datasets were collected by crawling Twitter accounts in multiple rounds, then collect the following and followers data. From the total of 1,125 users, there are 529 spammers and 596 non-spammers. So the researchers compare the performance of the proposed approach with 5 existing machine learning based state-of-art approach. So A, which use profile or account and content based features, B, which also use profile and content based features, C, which use profile, content, and graph based features, D, which use profile, content, and timing based feature, and E, which use profile, content, and time-based feature. And F and G, those are 2 deep learning-based approach, where TBC and CF is the proposed method. TBF is text-based classifier and CF is combined classifier. As we can see, over the dataset 1, the F-score of proposed approach is 99.68%. It gives the highest F1 score than other approaches. Similarly, in terms of accuracy, combined classifier gives better results, 99.32%. Likewise, the combined classifier's precision and recall value is 99.47% and 99.9% respectively, which are also fewer than those of the other considered approach. And here we see the result of datasets 2. It can be seen that the F1 score of combined classifier is 93.12%, which is greater than the other considered approach. Similarly, we see that combined classifiers gives accuracy, precision, and recall value of 93.38%, 95.31%, and 91.04% respectively. While the performance of simpler alternative architecture combined feature outperforms simpler alternative in terms of accuracy, precision, recall, and F1 score. So from this journal, we can conclude that the researchers developed a text-based classifier and combined classifier that considers just user's tweet text and combining user tweet text and metadata. This approach reached the highest accuracy at 99.68% and 93.12% on dataset 1 and dataset 2 respectively. Thank you.